Welcome to the lecture on multivariate input models. So, in this lecture we will talk about the joint distribution functions, then the covariance correlation among the random variables. So, as we know that in the simulation many a times we have to deal with more number of random variables. So, in that case when you have two random variables, that is when n equal to 2, in those cases p x y means the probability of x, you have x and y as random variable. So, if the x equal to small x and capital Y equal to small y. So, if that is, so that is basically known as the joint probability mass function of x and y. So, if p x y is equal to p x into p y, then they are said to be independent, and if they are not so, if the p x y is not equal to p x into p y, in that case they are said to be dependent, and p x x and p x y p y y, they are called the marginal probability mass function of x and y. So, these random variables may be either discrete or it may be continuous, and we must know how to see whether the two random variables which have been defined, whether they are independent or not. So, for that certainly if the p x y will be p x x into p x p y y, then you can say that they are independent, otherwise they are dependent. Now, before we go to that, now even this works well even for the continuous distribution functions. Now, so we must know certain definitions for that, as we know that. So, in that case p x x is nothing but for all y, this is p x y. Similarly, p y y is for all x, p x y. So, this way you find the p x x and p y y, and if p x y is equal to p x x multiplied by p y y, then we say that x and y are independent. Now, in the case of continuous random variables, this sign will be replaced with the integral sign, and in that case dx and dy will come whatever the random variable we choose. So, for example, we can have certain examples. Suppose we have an example which is given, like suppose we have x and y as two discrete random variables. So, they are defined like this: p x y, they are defined as x into y by 27, and for x equal to 1 and 2 and y equal to 2, 3 and 4, and this is 0 otherwise. Now, we have to see whether these two random variables x and y, they are independent or they are dependent. So, for that, as we know, if the p x y, so for that, as we know, if p x y is equal to p x of x and p y of y, then in that case x and y are said to be independent. So, this is the condition, and it is already defined what is p x x and what is p y y. So, let us find the p x x. So, p x x will be all the summation of all the values. So, you have p x y, so that is x y by 27 over all y. So, y is from 2 to 4. So, y varying from 2 to 4. So, for all the values, they are discrete values. So, we are taking every value y equal to 2, y equal to 3 and y equal to 4. So, if we do that, so in that case what we see, so y will be varying. So, it will be once 2x by 27 plus 3x by 27 plus 4x by 27. So, that is 9x by 27. So, it will be x by 3. So, we have x value as 1 and 2. So, we get Pxx equal to x by 3. Similarly, we can get Pyy. Pyy will be again summation of all x. So, x is varying basically for 1 and 2. So, that is x equal to 1 to 2, and in that case you have xy by 27. So, it will be once we take 1. So, y by 27 plus 2y by 27. So, 3y by 27, that is y by 9. Now, what we see is if we multiply, now what we get, whether we are getting Pxy equal to Px x into Pyy or not. So, if we multiply these two, Pxx into Pyy, it will be, we have got Pxx as x by 3 and this as y by 9. So, it is xy by 27 and it is nothing but it is equal to Pxy. So, it means x and y can be said to be independent. So, x and y are independent. So, this is how for a discrete random variable for the joint probability distribution function we can say and we can find whether they are dependent or not. Let us check one for the we can also check these this type of independence or dependence for even the continuous distribution function, and that we can do once we solve the problems in the next lectures or so. Now, further we must know that what is the dependence between two random variables. So, how the dependence is to be calculated. So, let us see how we do it for a continuous random variable. Now, let us take another example where x and y are continuous random variables and the fxy is defined as 32 x cube y 7. So, in that the range for x is 0 to 1 and y is again 0 to 1. Now, in this case again, because here we see that the x and y is defined in intervals. So, x and y are basically the continuous random variables. Now, in this case again we have to see, we have to check whether the x and y are independent or not. So, we will find fxx and this will be integral of fxy dy for all y. So, y is between 0 to 1. So, it will be 32 x cube y 7 integral dy 0 to 1. So, it will be 32 x cube into y 7 dy will be y 8 by 8. So, it will be 4 x cube y 8 and the y value is changing from 0 to 1. So, it will be 4 x cube and then next time it will be 0. So, it will be 4 x cube. Then fyy, this will be again, it will be fxy this time for all x. So, it will be dx and x is also varying from 0 to 1. So, this will be coming as integral 0 to 1 32 x cube y 7 dx. So, it will be 32 y 7 into x cube will be x 4 by 4, and this will be between 0 and 1. So, it will be 8 into y 7. So, what we see that we get f x x and f y y. Now, if we multiply them, f x x into f y y, it will be equal to 4 x cube multiplied by 8 y 7. So, it is 32 x cube y 7. What we see is that in this way we see that this is nothing but same as f x y. So, since f x y is same as f x x into f x f y y, it means x and y are independent. So, this is how you check if the random variable is either discrete or continuous, their dependence or independence can be checked. Now, we will have to see the dependence between the two random variables. So, the dependence between two random variables, for that basically there are certain parameters which are computed, and we compute the covariance, and covariance between two random variables is defined as cov x y, we write it as, and it will be E x y minus E x into E y. So, as we know that we have the joint probability distribution function or probability mass function. So, we have the E x y, we have to compute E x y, and then we have to compute E x and both E y, and then we have to get the difference of that. So, this way you get the covariance. So, covariance is basically a measure of the dependence between x and y. So, if we try to see what is covariance x x, so if y is taken as x, it is coming same as the variance of x. So, variance x we find as E of x square minus n times E x or E x whole square. So, this way we get the variance x. So, that is what we get when we get covariance x x. Now, what do you mean by covariance x y? So, when the covariance x y is 0, it means the x and y are uncorrelated, and if it is 0, I mean it is more than 0, it means they are positively correlated, and if it is less than 0 means it is negatively correlated. Basically, covariance is nothing but you have x 1 minus mu 1 into x 1 minus mu 2, x 2 minus mu 2. So, if it is more than 0 means if x 1 is more than mu 1, in that case x 2 will also be more than mu 2. So, that is known as positively correlated. If one value is larger than the mean values, then for another random variable also its values will be larger than the mean values. So, that is what the meaning of positively correlated. Similarly, if it is negatively correlated means the value is less than 0. In those cases, if one of the random variable has values less than their mean, in that case for the other random variable its value will be more than its mean. So, in those cases what will happen that their product will be negative. So, that is why if it is less than or more than 0, it has certain significance. Whenever we have independent random variables, they are said to be uncorrelated. So, normally you have the independent random variables, these are uncorrelated. Now, for the correlation there is another parameter which is defined, that is rho, and that is correlation x y. So, this is nothing but covariance x y by under root variance x into variance y. So, this is how you find the correlation, and this correlation will be varying from -1 to +1. So, if it is close to -1, it is highly negatively correlated, and if it is close to +1, it is highly positively correlated, the two random variables, and if it is near to 0, it means they are uncorrelated, they are independent random numbers. So, this is how you find the different correlation parameters by which you calculate and you come to the conclusion whether it is dependent or not dependent. Let us see how you compute the correlation and you come to this conclusion whether the variable is independent or not. So, before that, before we go to further see with the problem where we try to find the correlation, let us see that further if you have x 1 and x 2 as the normally distributed two random variables. So, their dependence can be modeled by the bivariate normal distribution. So, as we know that once you have the data, so in the normal distribution case you have the parameters like mu and sigma, that is mu is mean, sigma is the standard deviation. So, sigma square will be your variance. So, in those cases you will have mu 1, mu 2, sigma 1 square, sigma 2 square, and then you have to find the correlation x y. So, correlation x y, as we discussed, it will be rho, and if you have n independent and identically distributed pairs like x 1 1 x 2 1, x 1 2 x 2 2, x 1 n x 2 n, all that. So, in those cases how you find the sample covariance, that is given by this formula. So, as we see you have the covariance of x 1 and x 2. So, we are finding this by x 1 j minus this is x 1 bar. So, this x 1 bar. So, you have two random variables given and they are going like this. So, you have x 1 j and this is j 1 to n. So, x 1 j minus x 1 bar. So, that is your mu. Similarly, x 2 j minus x 2 bar, and then it will divided by n minus 1. So, this will be basically covariance. So, it will be nothing but 1 by n minus 1 j equal to 1 to n x 1 j x 2 j minus n times x 1 bar x 2 bar. So, this is how you are basically finding the covariance, and once you find the covariance value will be divided with this estimated value of. So, this is unbiased estimator of standard deviation 1 and 2. So, we had seen in the earlier formula, this was here it was under root variance 1 and variance 2. So, this is sigma 1 bar and sigma 2 bar. So, this is how you compute the correlation. Now, let us see how we solve if we face certain problems of that type. Now, suppose a problem is there like this, that you have x 1 which is average lead time to deliver and x 2 is the annual demand. So, you have x 2 as annual demand and x 1 is average lead time to deliver in months. So, these are the two random variables which you have the data, and this is lead time and demand values are given. So, for the first value is 6.5 and this is 103, then you have 4.383, further you have 6.9 116, you have 6 and 97, you have 6.9 112, then further 6.9 and this is 104. So, you have further 5.8 and this is 106. So, for the last 10 years, you have 10 data, further you have 7.3 and this is 109, then you have 4.5 and 92, and then you have 6.3 and 96. So, these are the data which you have for the two random variables. One is talking about the lead time, another is talking about the annual demand. Now, in this case you have to find whether there is any correlation between them. For correlation you need to calculate covariance. For covariance you need to calculate summation x1j x2j, and then you need to compute the mean, sample means for the two random variables, and also you need to calculate the variance for them, so that you get the standard deviation, and further you can get the value of covariance. So, if we do the analysis over this, what we get is, so x1 bar, for that we have to add these values, and these values once added it has to be divided by 10. So, this value comes out to be 61.4 and then you divide it by 10. So, it will be 6.14. Then similarly you have to find x2 bar, mean value of x2. So, x2 also again we are going to add these 10 values and divide it by 10. So, this is coming out to be 101.8. Now, we need to compute the sigma 1 and sigma 2. So, sigma 1 is calculated as, so this is the estimator value basically. So, this is computed up to be 1.02. Similarly, you compute the sigma 2 value, that is estimated value of sigma 2. So, that comes out to be 9.93. This can be computed using the standard formulas. For that you need to have the square, and then further we do the necessary computation. So, you can get the sigma 1, sigma 2, x1 bar and x2 bar. Another thing what you need is summation x1j, x2j. So, summation of x1j, x2j, and as we know j is varying from 1 to 10. So, what we will do, we have to do the multiplication of this and this, plus this and this, plus this and this, plus this and this, like that you have to multiply and then we have to add it. So, j equal to 1 to 10, this summation will come out to be 6328.5. So, this is nothing but the summation, suppose here 103 into 6.5 plus 83 into 4.3 plus 106 into 6.9 plus 97 into 6 plus 112 into 6.9 plus 104 into 6.9 plus 106 into 5.8 plus 109 into 7.3 plus 92 into 4.5 plus 96 into 6.3. So, this will come out to be 6328.5, that is x1j, x2j. That formula is shown here. So, this value is coming out to be 6328.5. Now, we have all the values, we have this value known, we have n as 10, x1 bar we know, x1 bar is known to be 6.14, x2 bar we know, so and we know also n is 10. So, we have to get the covariance. So, covariance we will be finding, covariance will be actually it will be 1 by n minus 1. So, 1 by 9, and then summation of x1j, x2j. So, that is 6328.5, and further minus n times x1, x2. So, n is 10 times x1 bar and x2 bar. x1 bar is 6.14 and x2 bar is 101.8. So, this is coming out, we have to do this computation, and this will come out to be 8.66. So, this is coming out to be 8.66. Now, we have to find the correlation, how they are correlated. So, for finding the correlation, you have to divide this covariance x y with sigma 1 estimator, sigma 2 estimator. So, sigma 1 estimator and sigma 2 estimator we know. So, correlation x y, that is estimator rho, this will be covariance x y divided by sigma 1 estimator, sigma 2 estimator. So, it will be 8.66 divided by x 1 bar is 6.14. So, this is sigma 1 bar is 1.02, and then it will be 9.93. So, this is coming out to be 0.86. Now, what we see is in this case the rho value, the correlation coefficient value, this value is coming out to be 0.86, which is very much close to 1. It means they are very strongly correlated. It means that whenever x is more than mu, in that case the x 1 is more than mu, x 2 is also more than its mean, but you can look at here by that. Now, in this case if you see the x 1 mean x 1 is 6.14. Now, you see, and the x 2 mean is 101.8. So, whenever it is more than that 6.5, in that case it is more than its mean. So, this both are higher. This is in this case if you look at, this value is less than its mean is 6.14 and this value is less than its mean. So, basically when you have x 1 minus mu 1 and you have x 2 minus mu 2. So, if the rho value is positive, is nearly plus 1, in those case if x 1 is more than mu 1, then x 2 will also be more than mu 2. In that case only it will be positive, and in those cases, so it will be positive. So, you can say that it is positive when x 1 is more than mu 1, in that case x 2 will also be more than mu 2. So, what we see, whenever x 1 is more than mu 1, the x 2 is also more than mu 2, its mean, demand mean and lead time mean. So, these values if you look at, this is the lead time mean, here it is 6.9, it is more than its mean, at the same time it is also more than its mean 101.8. So, in most of the cases we see that, in most of the cases we may not see in every case, but in most of the cases we see by looking at the statistics also it becomes clear, but then statistically if you find, you will see that how they are correlated. If it becomes 0, it means the data is quite random, they are independent data, that is what you mean to have it. And whenever it will be negatively correlated, in those cases if one value is larger than its mean, in that case its value will be smaller than its mean. So, in that case if you find the correlation, it will be coming in the negative direction, it will be having the value towards less than 0. Certainly the correlation coefficient value will be in between 0 and 1, but it will be close to minus 0.5, 0.6 or minus 0.7 or so. So, in those cases we say that it is negatively correlated, and whenever it comes 0. So, basically what we need to study later on, that we will have to compare these values. Now, the thing is that we have already studied the significance of that, and we had seen in the earlier lecture that what is the significance of this rho, and we plotted these diagrams, and we had seen that by looking at the curve you can say that this rho value how it should be, if it is close to 0, then we say that that data is independent. Thank you very much.